So as we can see, based on our continuation from the last episode, so you're all welcome to the class and to a continuation on implementing your first ML-based model in what we call the Hello World model and machine learning model, which is a important clarification series under the theme, always let the data speak. So we are going to continue in the same vein, but today might be maybe the kind of summary of this series, the 3-week series. And then after we are going to take a couple of clarifying questions where applicable. So last time in the previous section, we made us realize a very important iterative machine learning procedure, whereby it is very, very important to get your data set under the data preparation, data modeling, the performance measure. And I say there's always room for you to go back and improve upon what you have actually done. So we also discussed the cases of few cases of samples, like diabetes disease modeling, which is a very, very important issue in our community today, in the world all over. So we discussed this data set, and then we try to actually make a kind of model out of it using the weaker environment. We look at this. This is the diabetes data set from hospital data. So these are from database of any medical center, could contain things like this. However, we also mentioned the idea of we getting our data from the interview. So we actually also consider another data set that was gotten from interview or questionnaire served from people, which is actually one of the way to revolutionize the way we use machine learning or data science. Because data science, data availability of data set is always a big challenge to whatever we want to do. So in essence, even when the data is available, the participating party might not be willing to release their data set and also for others. So why not we think out of box, also come up with our own data set? There are some very, very important, simple questions that we might actually use to get data from both the healthy and the sick people, which we can actually use and turn it into very interesting knowledge that can support our decision-making process. It could also be in any other field of endeavor. So after that, also we actually look into customer churn, a case study of telecom company also, whereby we had data set already gotten from a company, and then we have series of, these are the attributes that were used in those examples. We did mention to us, even though these were the features that they identified that were provided by the owner of the data set. We also mentioned that looking at this data set, we noticed that age is conspicuously absent. And age could also actually determine, so a customer that is going to run away or not, the youth has their own unique attributes or characteristics or pattern of behavior when it comes to staying with a particular product for a long time. So while an adult might want to stay longer, youth might not have that particular patience to stay longer. So whenever a new one comes out, they might want to join to at least check out what they have enough for them. But an elderly person might not really have that time. So either being busy or doesn't really care much. What matters is for them just to make a call. So it means an elderly person might actually not leave a particular telecom company for a long time, whereas youth might quickly leave and join another one, might come back later. That's why we felt that the data set not having age might be actually lacking very important information. We say, okay, we can propose us to add age to it. Because you, as a machine learning model developer, you have a very big role to play in guiding the client to know which information is important. You see, you have to think together, and using your experience of what you have done for people before, you can make suggestions to them. To them, those are the variables they were thinking about. The accounting week, number of weeks the account has been active, the contract renewal, data usage, customer service, but they never thought about the issue of age, which to me is very, very important. Age can go a long way in determining the customer that might leave or that might not leave. And also gender. We also need to see, okay, what is the effect of gender in maybe a customer is going to leave a telecom company or the other. So you may make suggestion to them that the next, definitely this data set should definitely be present in their database. And any telecom company will know your age because you have to register with them. So they have the age, they also have the gender. Is it male or female? But somehow they didn't include it in the data set supply because maybe they didn't consider it important. See, this is why when we build model or when we request for data set, we always tell our client to provide as many information as you have. Because sometimes they might actually remove very important information before the data gets to you. To them, thinking that customer service call is very important, the number of days, minutes, monthly charge, and the like. But however, when you run the model, you might find out you're facing some challenges, you are not able to get the appropriate information. But quickly looking at it, personally, I was able to identify that age and gender should be part of this data set. And when you analyze it, even from kind of demographic point of view, you'll be able to see that, yeah, age should be able to matter. Of course, we always want the principle of let the data speak, because sometimes also experts, we explain and opine that, okay, these are the attributes that are more important in this area, get them. But the advice we always give out is please get as many as possible. In fact, all the information that is in your database, with the exception of any information that can identify the customer or the patient, this is the only thing you should remove from the list. For example, their name, we don't need their name, their ID, maybe national ID or social security number, anything that can be used to trace that customer, we don't need them because these are very sensitive information. So people's information need to be protected. So we, in data science machine learning experiment, we are in need of anonymized data. That is data set that you've removed anything that can actually identify the actual owner of the data set. And when you are going out to solicit for data, you need to mention this. It's very important. Not a lot of them start thinking, oh, he's going to reveal our information to the other people. Even sometimes when they agree to give you the data set, they might still also tell you that, okay, this data set must not be published until after so number of years. But going to ask data from client means you need to give them back that kind of assurance that, yeah, you are not going to use the data set for what is not going to be good for your company, and we're going to protect. In fact, ask them not to include the name of their customers or patient if it is medical data, as the case may be. This will go a long way in convincing them to hopefully cooperate with you and then to get your work done. So we did this last time and we were able to look at it and then we check. I also run it on the system and then see the way it actually went. However, so today we are going to look into what we call the summarized steps on getting started with the ML modeling, the Hello World ML modern series. So what are the steps we have to take? So everybody gets it very clearly. So, and everybody can come on board as soon as possible. It's not something that is difficult. So the first thing is to identify your area of interest. Identify your area of interest. So if you are not, maybe you are not from computer background, yeah, so maybe your own area of interest might be your own specialization. but sometimes it might not be. You might be interested in some other area, maybe tangential or a little bit closer to your area. So identify the area of interest that you really want to model. Because the good thing about machine learning is it can be used for any problem. Just think about it. The only thing that can prevent you from using machine learning is non-availability of data set in that area. So once you identify your area of interest, then the next thing is to look for free online data set to start with. Try to check. Look for free online data set to start with. Because if you want to start collecting data right from that beginning, well, number one, you might not actually know which kind of data set you are going to collect. This is why it's very good to start with online data set. This should be the starting point on any project you want. Try to look for online. Is there any data set there? Because when you get the online data set, it will guide you to see, okay, this is there. Okay, these are the features they have used in their own case. But in my own case, do we need all these features? But if you are going to a new area for the first time, you don't even know what are the attributes that might be in there. In fact, some of the attributes you are thinking about might not be relevant. So getting a kind of online data set will put you on a very good starting point. I want to get the online data set, and there are so many online data sets. We presented some of the link in our forum. You can check it out. Somebody also can help us repost some of those free data set. So among them is the Cargo, very, very popular. You can search it on. You have a lot of data set to check for yourself. Cargo data set is a very, very big and a popular data source. So we also have the UCI data repository, so very popular also. And then one of the advantages of using this data set is often when you have any data set from this source, they will mention if there is any work that has been done in that area earlier. They will list those papers that have been published related to those data sets. So in that case, you can easily have a particular work that you want to build upon, or at least you want to have an idea of what they have achieved before. Because it's also very, very important in this area, irrespective of your background. Either you are a researcher, you're a practitioner in industry, it's always good to see what has been done before with that particular data set that you have gotten. So once you get your data set, the next thing is to quickly launch your building environment. So very simple one is Weka. It can be any environment you like. It could be MATLAB, it could be Python, could be anything that is used as data science analytics environment. You are free to use that. But for here, we encourage Weka because it's very, very simple and very easy for anyone to easily use and build. So build your first ML model and build that. So if you refer back to our 2 or few videos, we see how to build that. We show you, we indicated that. Do your hyperparameter optimization. This is very, very important. See, hyperparameter optimization means that you have to identify what are the hyperparameter for that algorithm. And it's always very good. When you're building your first model, always start with simple algorithm. This is the principle of machine learning. Start with simple algorithm. And what the simple algorithm is the KNN, K-nearest neighbor. K-nearest neighbor, which is like, show me your friend, I tell you the kind of person you are. So select that, you can still run and see how it is working. Then you can from them move towards more complex algorithms. So decision tree also, another one to check out, decision tree. Also very interesting, Bayes net or naive Bayes. These are very simple machine learning algorithm you can quickly select. And then depending on the need, so make sure you check the hyperparameter. Optimization is very important. So for example, in KNN, the hyperparameter include K and the distance measure. Distance measure, very important. So K could be 1, it could be any number, but if it is classification, and you're having two classes, then it has to be one. Sorry, it has to be two. Yeah, K could be 1, it could be 3, it could be 5. If your number of classes is 2, to prevent tie, because it's a voting, it's based on voting. It will assign the nearest neighbor to you and then vote. If the neighbor nearest to you is positive, then how many of them are positive? 2 nearest neighbors are positive, 3 of them are negative, then you will be assigned negative. So, but if your neighbors, the nearest neighbor to you, majority of them are positive, you are here, then there are 2 nearest neighbors to you that are negative, your class will be assigned to be positive. So based on this, we don't want to select odd even number, because if you select even number, you might run to a situation whereby you're going to have 1 negative, 1 positive close to you. In that case, you don't know where you belong to. So that is why if you are dealing with 2 class problem, then you have to select your K to be an odd number. But if you have more than 2 classes, multi-class problem, in that case, you have to be careful that the number of classes is not going to be a multiple of the K value you are going to select, just to avoid a tie. So once you have done that, then sometimes also you might have to select the algorithm, change the algorithm, search for, try different ones and see the one that works for you. Sometimes so feature selection might be needed to get your result better, but then we do be later. We'll discuss this one later. The next is to analyze your result. Once you have done that, analyze your result, see how you are faring. Analyze your result, see how you are faring. So check it out. Is it good? Then document your experimental outcome and findings. Then disseminate your result in case of interesting findings on improvement or improvement. I want to mention here that even though you are using online data set, it doesn't mean that you cannot make contribution in this area, especially from researcher's point of view. Yeah, you can get online data sets, you can actually get the outcome of your experiment published. You have to, of course, do the initial literature survey of those people that already work on that data set. See what they have done, then what is their achievement. Sometimes you see they work on it, but they were not able to achieve the maximum possible. Maybe they were getting like 85% accuracy, for example. Also, you notice that the first negative were very much for if it is a medical application. And also the number of features being used, like 27 features to solve a problem, is too much. Then you might come up and say, oh, I think I can make contribution in this area. One, I need to try to improve this performance to like maybe 95 or 99 or as much as possible. Or sometimes also I want to investigate feature selection. 27 feature is too much. Collecting 27 feature is not easy. It's going to be very costly and also time wasting. And at the same time, it could also be this reason why they couldn't get excellent results, because the features are more. And the more the number of features, then the more the number of samples you need. And often the number of samples are fixed. This leads to what we refer to as cost of dimensionality. Cost of dimensionality. That is, as the number of features increases, then the number of samples needed to achieve reasonable result increases exponentially. So an exponential increment is dangerous, is difficult to meet. So this is why you might have to look at it as, okay, what have they done? Oh, there's still limitation in that area. In short, you try to get gap, create gap, look for gap in the earlier work. And then based on that, you now run your experiment, analyze it. So we can check out one of our earlier specific video that has been dedicated to how to look for gaps in machine learning research or machine learning based research. How you can identify the gap identification. We discussed this in detail in the past. So you just have to look for a gap in that area, and then you can actually document your experimental outcomes and findings, and then you can disseminate your results in case of interesting findings, or you're able to make improvement. Could be in conference paper, it could be even in journal paper, depending on what kind of gaps you are able to identify and what success you are able to record in your experiment. Now, so moving further, having tried your capability out on the free data set or the online data set, then based on the experience from the online data set, try to gather new data related to this area of your interest now. Now, the good news is this: the fact that you have worked on online data set and even got it published, it doesn't prevent you from working on the new data set. Actually, that new data set is like a new contribution on its own. You have to pay attention to that. So getting that new data set is actually like a new contribution on its own. And when you use your machine learning algorithm on it, you can easily get it out there as a researcher, get it published. Yeah. Even though the same samples, the same features you use in previous one, whatever. But this, because this is the challenge of data science. You cannot really generalize easily. The fact that one data set performs from one part of the world doesn't mean it's going to work in another country, because the genetic makeup of those country people are different, the lifestyle are different, so a lot of things. So we always need to investigate using data set from another area. So the next level people are looking at is, can we have an heterogeneous data set? That is, data set from different places, push them together to train a very big system that can identify or predict any system from any part of the world. That is going to be very, very challenging. Yeah, because the data set actually, they have different information that actually that are hidden inside them. So in this sense, this is one of the areas of future research target, to try to see, can we bring multiple data sets from different sources and match them together? That will even be the third category of your work. Anyway, so let's move on. So having demonstrate or practice on the free data set, now try to get your data set, your own new one. How do you do this? You can do that by contacting the interested parties or relevant establishments, requesting for the intended new data set. You may support them by providing them with needed attributes. We need these attributes, because often they will ask you, what kind of information do you need? For me, I always tell them, if there are people that already have a computerized system, I used to tell them, any information about your patient, let's say in medical, can you just release it to us, except just remove their name, remove their medical record number, anything that can identify them, remove it. Because they want you to be specific with the number of features. And sometimes there are some features that you don't even know them, and they might be holding the very important discriminatory capability in that data set. And they are known. They are features that we don't readily recognize, but they might be having very important discriminative power. Because the idea of getting different attributes is, you want attribute that can be able to assist you to differentiate between one class and the other. So we usually tell them, hey, can you just give us whatever you have in your system regarding your patient? If it is company, let them provide whatever information they have on that product you are trying to model. However, some of them will not, they will say, no, you have to tell us number of the specific attributes you want. Then in that case, you go back to your online data set that you have used, try to look at those attributes, then provide it for them, while still imploring them that, well, if you have other attributes different from this, please give it to us. Because the idea we are actually investigating is, we want the data to speak. Let the data speak. No one knows the particular attribute that's going to work. There could be some attribute that work for the online data set. It might not work very well in your own locality. See, that is why it is good to have several data attributes request, so that you can be sure that whatever you are going to get will work for the locality you are modeling. So once you get the data set, then we say all the best. Though sometimes also you have to take notes. Sometimes you may have to use interview or questionnaire. This is a very, very important suggestion for us. We should not give up. I've seen someone now for months has been following up with establishment to release data set, but they promised to release, but they didn't release it. One bureaucracy and the other promises. People face challenges. Imagine over 9 months, someone tried to get data set. It could be frustrating. So why not we go on interview questionnaire? With online system now, you can just make a very small Google form, spread it on your social media, employ people to please help you answer these questions. Make them as simple as possible, because experience has shown that even some very simple information, simple question and answer, if you can get the responses from diverse background related to the sample area you are looking for, it could go a long way actually to provide the needed data for you to be able to make a very successful machine learning modeling. So we have to pay attention to that. That data set could be gotten from relevant establishment, but don't restrict yourself to that. In the past, people used to always run after this establishment. At the end of the day, they might not get the data set. So why not also, while you are doing that, try to think out of the box, create a very small interview or questionnaire, and then try to get answer to it related to that area that you are modeling, if it is applicable. We know some areas might not be applicable to such a kind of interesting idea. Then once you have got your data set, either directly from the establishment or from the interview, then do the new modeling using the new data set again. So we have to do now another modeling using the new data set. Doing the modeling involved doing the hyperparameter optimization again, selecting algorithms. Sometimes you might have to use more sophisticated algorithms, including using ensemble. We go for ensemble when things get really tough. When you cannot get excellent result you are looking for, then you start to match together different types of algorithm to form one in a kind of what we call it's a committee machine. It's like you form a committee of different algorithms, you train them on the same data set, and then they can vote to select the final answer for you. Or in special cases, we can use stacking, whereby the outcome of each of all these individual machine learning models, they are then used to train another model to generate the final result. So whichever option you use in ensemble types is also an option to look into. So we can check out some of our description in our earlier videos on ensemble machine learning modeling and how to build different types of it. After that, also, as usual, you go for analyze, document, and disseminate your findings or outcomes. It's always very, very important. Even in industry, whenever they do anything, any modeling, and get the outcome, they try to disseminate it. It's very, very important. You see, that's why these days you have a lot of R&D in companies, try to let people know what they are doing in conferences, in different outcomes, especially Society of Petroleum Engineering. They do a lot of conferences, encourage their members, their staff to showcase what effort they are making and the outcome they are getting. So it's always encouraged, whatever you have gotten. Don't underrate yourself. Try to prepare it, document it, and disseminate it so that other people also can benefit from the effort you have actually made. So sometimes, for the sake of maybe kind of being very, if you are somebody that you like to try out many things, you can think of, is it possible for us to merge data sets from the one gotten new with the one from online if they share the same number of features? Can we merge them together to investigate and see what's going to happen? Like I said, heterogeneous data modeling is one of the next generation of modeling that people are looking at. But it's very challenging, it's very tough to train a model on the data from one sample. I want to predict from another sample, from another country. It's very challenging. That's why every modeling that uses different data set is considered a new modeling outcome. So until then, that we are able to have the capabilities to merge data together and still get reasonable results, we will continue to still go by way of individual data to their individual modeling and then outcome. So those are what I call the summarized steps that you can use to get started with ML modeling, especially for the new one, and also as a revision for those who are already on the task of modeling using machine learning. So I believe this is where we're going to call it a day for now. So if there's any question, we're going to take a few questions of clarification regarding what we have presented or any other issue that we want to seek clarification for. So we can do that by raising up our hands in the system and then to recognize you. Thank you very much for listening, and I wish you all the best. Thank you.